Okay, in this video we're going to apply the things we've learned about permutations and combinations. We're going to apply it to probability. They actually work in conjunction. And so let's go back through some basic things about probability just very quickly. Things you should already know. So the idea of this thing called an event in probability has a particular meaning. And an event is something occurring or choosing something in particular. So something occurring or chosen or an action. And it's a little bit different to the general word event, and you've probably seen that before. Sample space is another one, and it's basically a set, and it's a set of all possible outcomes. Okay, so these are things you should already know. In the basic formula for probability PR, or sometimes just capital P, of an event A. One way of defining that is the number of outcomes in set A or the number of ways that A can occur. So the number of elements associated with A, or the number of ways that A can occur, event A, over the total number of outcomes. Total number of outcomes. So they are things you should know already. And just a few things, because we're going to apply permutations and combinations. Remember that permutations, when we're talking permutations, we're talking ordered, so order is important, ordered arrangements, okay? So when we're talking about order and arrangements, that's permutations, and combinations is about ways of selecting. So there's selections, and don't worry about the order with combinations. Okay, so again, that's all stuff we've learned before. Associated with permutations is NPR, arranging n things r at a time, and we've seen that's n factorial over n minus r factorial. With combinations we have NCR, which is choosing n things r at a time, or choosing from n things, we're choosing r or r at a time, r from n. Okay, and we've got we've seen in the past too that we've got this n factorial over r factorial times n minus r factorial. Okay, so again, that's all stuff we've covered, but sometimes it doesn't hurt to do a bit of revision. So let's look at an example now. We have 4-letter words. We're going to create a 4-letter word, not of the naughty type, I hope. 4-letter words are to be made by arranging the letters from S, P, E, C, I, A, L. So what is the probability that the word will start with a vowel? So we need to work out, are we talking permutations or combinations? And the word arranging is synonymous with permutations. So we're looking at NPR. It's the first thing to establish, and NPR is n factorial over n minus r factorial. So there's a good chance we're going to apply that. Alright, so what information do we need to engage with? Because of the definition of probability, which was back up here, and that is the number of outcomes in A over the total number of outcomes, we need to get the total number of outcomes first. So we're looking at the bottom of that probability. So bottom of that probability formula, the total number of outcomes, the total number of outcomes is we can use NPR for that. So total number of outcomes 7p4, which is 7 factorial over 3 factorial, which is 840. So that's basically, because the 3 factorial parts cancel numerator and denominator, you're left with 7 by 6 by 5 by 4. Now, if we've got 3 vowels here and they must start, you basically got in the 4 positions using the multiplication principle 3 by 6 by 5 by 4. So that first number is changed down to 3 for the total numbers of ways that this event can happen, and that comes out as 360. So the probability of this event, if we can just call it A, you should probably define that, let A be this event that we're talking about here, is basically 360 over 840, and we just simplify that to 3/7. Alright, so in the second example here, 3 students are to be chosen to represent the class in a debate. Chosen. Alright, now the order is not important here. If you're choosing people, we ignore the order, we're looking at combinations, okay, or selections. So we're looking at NCR situation, and if the class consists of 6 boys and 4 girls, that's important information. Alright, 6 boys, 4 girls, and basically we have to choose 3 in total. What's the probability that firstly the team will contain exactly 1 girl? So we write this down here. Let's look for that. What part of NCR do we need to apply? Well, for the total number of outcomes, which is the denominator, we need to look at 10C3. That will give us the total number of teams that are possible, because it's 3 outside of 6 plus 4, 10. So that's 10C3, which is 120. Now, for the number of ways that can happen, we need to realize that we're choosing 1 girl and 2 boys. So we're looking for the numerator of our probability formula. Okay, so we're going to use an NCR for each of those, and basically we've got 4 girls and we're choosing 1 out of 4, and the N means multiply, so multiply. We've got NCR for the boys, and that's 2 from 6. That's how many ways that can happen. So we calculate that, 4 by 15, and that equals 60. So the probability of this event, if we're defining it as A, doesn't matter what symbol you use really, I'm just being consistent, is 60 over 120, which is 1/2. Finally, the last example, at least 2 girls. So at least 2 girls means basically we've got 2 girls or 3 girls. Two girls or 3 girls. So we've got to look at these two separately. So for 2 girls, we look at that there, it's 4C2 times 6C1 because we've got choosing 2 girls from 4, or choosing from 4 girls, choosing 2 at a time, and there's room for 1 boy then out of 6, so choose 1 boy from 6, so from 6 choose 1 boy at a time, and basically multiply those together we get 36. So that multiply refers to an and. You're choosing 2 girls and 1 boy, not to be confused with the or. That means this can happen in 2 different situations. When we get to this or, we're going to add, and means multiply. That's from our earlier principles in the course. Okay, now for 3 girls, we've got out of 6, we've got boys, we've got to fill up 3, we've got no boys. Okay, so that is 6C, 0 for the boys, and 4C3 for the girls, choosing 3 from 4, so from 4 choosing 3 at a time, and multiply those 2 together and you get 4. So we've got to add those together, so we've got 2 girls or 3 girls, so therefore we have 36 plus 4 ways of that happening. It's 40 ways of that occurring because of the OR factor. Alright, final step. In the final step, remember we had 120 possible teams and we have 40 ways. So we go 40 over 120, which